Determine whether there is a minimum or maximum value to each quadratic function. Find the value and the axis of symmetry. Here we have f of x equals negative 4x squared plus 6x plus 9. So first off, let's talk about the minimum or maximum value. You should be aware that every single quadratic is always going to have a graph that is a parabola. And those parabolas can either open up or they can open down. But regardless, wherever we have the vertex of the parabola, we have a minimum or a maximum value. And that's the value that we're referring to. But as I said, this always happens at the vertex. So essentially, this question is asking, is there going to be a minimum or maximum, and what is it? So to determine that, what we need to notice is that the leading term coefficient here is a negative number. And when the leading term coefficient is negative, so we say when a is less than 0, because the standard form, or the general form of a quadratic is ax squared plus bx plus c. So the number multiplying the squared term is a. So when a is less than 0, what happens is that parabola is going to be facing downward. And if the parabola is facing downward, the vertex is going to be a maximum. So we are looking for a maximum value here. Now, as I mentioned, it's located at the vertex. Well, the vertex can be found through a couple of means. One is to rewrite your equation in terms of a standard form, which is the a times x minus h squared plus k. Or you can more quickly get the vertex if you use the formula negative b over 2a, comma, f of negative b over 2a. Just be careful with the vertex formula, as often people forget the y value of this. This part right here, which is easy to remember, is just the x value. In this case, the x value of the vertex would be located at negative b, so b in this case is 6, over 2 times a, and a is negative 4. So I have negative 6 over negative 8. The negatives will cancel, leaving me with 3/4. Now, in order to get the y value, what we have to do then is evaluate this particular function at 3/4. So this would be negative 4 times 3/4 squared plus 6 times 3/4 plus 9. And when I square a fraction, you can square the numerator and denominator separately. So 3 squared is 9, 4 squared is 16, plus, looks like this would be 18 over 4, plus 9, and actually I'll go ahead and change that to fourths as well. So 36/4. And what's nice, one thing that's nice, is 4 is going into this 16, leaving me a 4 in the denominator. So this is actually negative 9/4 plus 18/4 plus 36/4. Negative 9 and 18 give me 9, 9 and 36 give me 45, so 45/4. So the vertex itself, in this particular case, my vertex is located at 3/4 and 45/4. Now, we did say it was a maximum, but the maximum value is just the y-coordinate. So actually how high that particular maximum reaches. So 45/4 is the maximum value. Now the last thing that's asked about is the axis of symmetry. So the axis of symmetry is just a vertical line that passes through the vertex. And it parts a parabola into two perfectly synchronous sides. So this right here is our axis of symmetry. And the axis of symmetry has a very easy formula. It's just x equals the x coordinate of the vertex. Because an equation of a vertical line is x equals a constant. So the constant that just happens to be passing through our vertex is what we want. We already have that here. That's 3/4. So the axis of symmetry is x equals 3/4.